Okay, done ready, yeah?
X equals
Okay, I repeat again. So for question number 10, right? For question number 10, uh, the first part, they ask us to prove that sine inverse x equals to ln x plus square root of x squared plus 1, and deduce that cosec inverse x is equal to ln, and then inside the bracket, you have 1 plus square root of x squared plus 1 over x. So for the first part, sine inverse of x, I'm not going to prove it. So we go straight to the second part. So let y be cosec inverse x. So what happened here is we write cosec y equals to x, right? So what is cosec y? Cosec y means the reciprocal of sine y. So reciprocal of sine y equals to x. And therefore, you flip the two of them, the two sides. Therefore, you have sine y equals to 1 over x. So therefore, y is equal to sine inverse 1 over x. And what is cosec inverse x? Cosec inverse x is actually our y. Therefore, now we proceed from there. Cosec inverse x is equal to, according to the definition just now, it was ln, what really I forgot, ln x plus x squared plus 1. So you have ln, and then you have 1 over x here, okay? Because the subject inside the bracket is now 1 over x. So you have to replace the x with 1 over x. So 1 over x plus, and then square root of, then you have 1 over x squared plus 1. Close the bracket. So now move on. Because of insufficient space, I will put it here. So this is equal to, you simplify the two of them, you have 1 over x plus, then this is square root of 1 plus x squared divided by x squared. And now you can see the answer is quite obvious. So the answer is therefore ln 1 over x plus square root of 1 plus x squared divided by x. Hence the answer is obvious. So this is ln of 1 plus square root of 1 plus x squared divided by x. Okay, so that's how you prove this one. Next part, find the integer n which is such that ln n equals to sine inverse 3/4 plus cosec inverse 3/4, right? So you have the sine inverse, you have the cosec inverse, so you will have to make use of the, like, so you have to make use of this one, sine inverse x, and also cosec inverse x formula. But for sine inverse, you replace the x with 3/4. And then for the second one, cosec inverse, you replace the x with 3/4 as well, right? Now for question number 10, I'm not going to solve it for you right now. I want you to do it later. Then you give me the answer by 10 o'clock. Okay? So for question number 10, I will leave it to you for the second part. All right? I want the integer n. So please take note. I already said that this is integer n. Okay? So you give me the solution later. Clear? So for this chapter, basically, I repeat one more time. What have we learned? Number one, we learned the 6 definitions of the hyperbolic functions. All right. So the most important two would be cos x and also sine x. Number 2, you must remember that cos x has the minimum value of 1. And then for sine x is a set of real number from negative infinity up to positive infinity. All right. Furthermore, for cos x, this is symmetrical about the y-axis. All right. So this is the graph. For tanh x, y equals to tanh x, make sure you remember that the graph lies between -1 and also 1. So this is for tanh x. Then after that, you have to remember some of the standard hyperbolic identities, because we use the standard hyperbolic identities to solve equation. So you can use anytime, right? So Osborne's rule means you have to be careful when there is this sine squared in the trigonometric terms. trigonometric identity, the sign terms are. So whenever a product of two signs occurs, change the sign of the term. So this is the rule that you need to know, right? Then after that, how to derive the formula. So this part here, you don't have to memorize because it's given in MF 19, right? But you need to know how to derive the cos inverse x, sine inverse x, tan inverse x in terms of logarithm. So for sine inverse and cos inverse, because the two of them are one-to-one function, so no issue. The only problem is with the cos x, right? Sorry, cos inverse x. So for cos inverse x, you will have to make use of this remark here. So please pay attention to this part here, right? So you need to restrict the domain, right? You have to restrict the domain. Therefore, this one would follow, right? So x greater than or equals to 1 and y is greater than or equal to 0. So basically, this is the end of lecture 2. Any problem so far? So if no problem, then we will proceed
I
with
think we did it
this part,
already. I think
the
you
new
did
one,
the same thing.
lecture
You let y
4. All
equals
right.
to shine
I will send you the
inverse
file
x.
later, the uh,
Then we
Samsung
just
Note file,
dude, there's
as
75
usual.
questions in the new
Right.
lecture.
Now for lecture 4,
You go see lah.
we are going to deal with the
Yeah,
differentiation. Now, this
there's
one you have to pay
28
attention.
pages.
This one you have to pay attention because I don't think they will ask you a lot of questions in terms of hyperbolic function alone. They would prefer to ask the questions which involve the differentiation, integration, and then for the differentiation, probably they will ask you to find the stationary value, stationary point, and therefore you have to solve the equation in hyperbolic form. All right. So we are going to look at the differentiation this round. But before we talk about the hyperbolic functions, we start with the differentiation of inverse sine and inverse cosine. So
Everything looks
to
so
find the
big.
differentiation of this one, you need to look at the graph, yeah? So if you look at the graph for the red curve, y equals to cos inverse x. You see that this graph is always decreasing. So when this one is always decreasing, this one indicates that the dy dx is less than 0 all the time, okay? All the time. Then you look at the graph. Okay, all the time means for all real values of x. Then you look at the blue color graph. So for the blue color graph, you have this from negative pi over 2 going up to positive pi over 2. This one is positive pi over 2. This one is negative pi over 2. All right. So if you look at this part here, this implies that our dy dx, later when you differentiate, you look at the gradient is always greater than 0 for all x, for all real number of x. So this would be very useful, right? Why is it useful? Because it helps us to determine the sign later. Let's look at the proof given at the bottom. Right. You look at it. I start with y equals to sine inverse of x. Okay. Now, when you let y equals to sine inverse of x, okay, this is what I'm talking about here. Maybe I just use not so obvious color so that you
Yeah,
can
we
follow
need
me.
the
Y
proof
equals
for
to sine
sine
inverse x.
inverse
And
cos
of course,
inverse
we
and
have
tan
to
inverse.
limit this one to 1 to 1. So when we limit this curve to 1 to
We just
1,
have to
then you know
copy
that
that
your
lah.
x must be in between negative 1 and 1, and your y value must lie between negative half pi to half pi. Okay, so we are considering the y equals to sine x 1 to 1. Y equals to sine x in as a 1 to 1 function. All right. So what happened now is y equals to sine inverse x. That would mean x is equal to sine y. So x equals to sine y implies that dx dy is equal to cos y, because most of you know how to find the differentiation of sine y with respect to y. So dx dy is equal to cos y, meaning that dy dx is 1 over cos y, right? So that is the reciprocal. We are using the chain rule. Now, this derivative has to be expressed in terms of x because I'm talking about dy dx. dy dx means the expression must be in terms of x. So we have to use the Pythagorean identity. So using the Pythagorean identity, we have cos squared y is equal to 1 minus sine squared y. So you rearrange the whole thing here, you have cos y equals to, now because you have cos squared y, so when you throw the square to the right hand side, you should have plus minus here, right? However, if you look at the graph later, right, so you're going to have plus minus square root of 1 minus x squared, plus minus square root of 1 minus x squared. The question here is, should we take the positive or should we take the negative? So you look at the graph above, you know that your dy dx is greater than 0. For sine inverse of x, the graph is always increasing, isn't it? So when y is increasing, the dy dx is greater than 0, meaning you must reject the negative value. So when you reject the negative value, therefore you can say that sine inverse, the differentiation of sine inverse is equal to 1 over square root of 1 minus x squared. Okay? Now, if you ask me whether the proof here is important or not, actually, I don't think this is important. I don't think they will ask you to prove the formula sine inverse x, all right?
Yeah,
Even
almost
if they
sure.
ask you also,
Yeah.
it's not very difficult. Just look at how I did it,
Okay.
all right? So we go to the next part. We will go to the next part. Now, these are the important formula given in MF 19. So for sine inverse, this part we have just done,
We're
right?
doing the first
Then the
topic
next one
first,
is
not
cos
the second one
inverse.
now.
So we are going to prove
Huh?
that cos
We're on the
inverse
second
has
topic
the
now.
negative value of 1
Yeah,
over
yeah, we
square
are,
root
we are.
of 1 minus x squared. Basically, the proof is the same,
But he hasn't even gotten to
right?
hyperbolic functions yet, right?
So I
It's just
save
the
this one.
normal
I
trigo
save
function.
first.
Those are the hyperbolic functions. What do you mean?
So I create new notes.
No, right?
This is for
What, the sine,
differentiation.
cos,
Yeah.
tang? That's the first
No, no,
topic.
just now he was explaining the normal trigo functions.
Really, man? I don't know.
Yeah.
Probably, yeah. I don't know.
Okay.
You see, lah, you
So
see the graph.
we
It's cos,
continue with
not cosh. It's sine, not shan.
how much time left? Can someone please check for me?
I don't know. Wait, how do you even check? Oh,
Okay. 26. So we have about 15 minutes. Okay, 15 minutes. So differentiation. So we start with cos. Let y equals to cos inverse of x. So I want to do this one. Therefore, I have cos y equals to x. Therefore, I know that dx dy is equal to negative
oh
sine
no.
y, right?
We're joking. There's
So
75.
you
Huh.
flip this whole thing again. So you have dy dx is equal to negative
But not
1
including
over
the examples, right?
sine y, right? So now the question
Yeah,
here
there's
is,
just a lot.
how do I find
Still.
sine y in terms of x? Because you see, this one is actually in terms of x. Therefore, I need to express this thing in terms of x. This is dy
I have
dx.
a feeling
So
this
this
topic
one
here
must
is all
be
about
in
arithmetic
x. It must be in
and
terms
a lot of
of
substitutes.
x. So move on. So you use the Pythagorean identity similarly. So you know that sine y should be equal to plus minus square root of 1 minus cos squared y. But you know that cos y is actually x. So plus minus square root of 1 minus x squared, right? So going back to the graph just now, I told you before that the dy dx is always less than 0. This is always less than 0. Therefore, you can only pick the positive value here so that it is less than 0. So therefore, you have to use the positive value. So therefore, you have dy dx. This is equal to negative 1 over square root of 1 minus x squared. Okay? So that's how you differentiate the cos inverse. Now, I hope you still remember what is the differentiation of, so this is in P3, yeah? What is the differentiation of y equals to tangent inverse x? Can anyone recall? dy dx is equal to, what's the answer? You learned this in
1
P3.
over x.
Was it 1 over 1 plus x squared or something?
Can anyone answer? Hello?
There was.
Can you hear me?
Oh,
I,
1
wait.
over x squared plus a squared.
The differentiation,
No one.
differentiation, or
I thought I gave you here.
it's 1/1 plus x squared. Lol.
1
Tangent
over
inverse.
1 plus x squared.
Yes, 1 over 1 plus x squared. Thank you. Who is that?
Oh, finally, hor.
Who is that giving me the answer?
Me, Zuyan.
Zuyang.
Ah, Zuyuan. Okay,
Ah,
Zuyuan,
yeah.
focused A star lah. All right. So no need to go for exam anymore lah, Zuyuan. 1 plus
Oh, the recording.
x squared. So dy dx is equal to 1 over 1 plus x squared. This is what you learned in P3. So we skip tangent inverse. Now we go to the next one.
It's okay, we're good.
Okay, so cos inverse settled. Next, we go to sine x. So for sine x, what happened? So you have, say I use red color, let y equals to sine x. Okay, so you want to differentiate this one, it's quite easy. You use the definition of sine x, right? So you use the definition of sine x means you have e to the power of x minus e to the power of negative x divided by 2. So what is the dy dx in this case? So dy dx means you differentiate the exponential x. The over 2 is just a constant, so I factorize the 1 over 2. Then you differentiate e power x, you have e to the power of x. So you differentiate negative e to the power of negative x, that would give you positive e to the power of negative x. Now, what function is this? E to the power of x plus e to the power of negative x divided by 2. What function is this? It is actually cos x. Therefore, if you compare with the differentiation in trigo, they are quite similar, but still I want to say, be careful, all right? So you have the differentiation of sine x equals to cos x. So this part is settled. So similarly for cos x is also the same thing. So for cos x is also the same thing. You do the same thing. That means you let y equals to cos x. Then you have dy dx equals to, now you are differentiating 1 over 2 and then e to the power of x plus e to the power of negative x. And therefore, it is quite obvious that this will give you half e to the power of x minus e to the power of negative x. And this is actually the definition of sine. So you have the differentiation of cos x will give you a sine x. So this part also settled. Next one, what about tang x? Okay, so for tang x, you can use the product rule or quotient rule. I think using quotient rule. So you have let y equals to tang x. All right. So when y is equal to tang x, by the definition, you know that tang x means sine x over cos x. So you have a sine x over cos x. So you have sine x over cos x. So dy dx is therefore equals to, you use the quotient rule. So the quotient rule means you copy the bottom, differentiate the top, then minus, you copy the top, differentiate the bottom, then divided by bottom square. Okay, so therefore you will get cos squared x minus sine squared x divided by cos squared x. And using the hyperbolic identity, cos squared x is actually 1 over cos squared x. Sorry, I said cos squared x minus sine squared x is equal to 1. Sorry. Okay, it's not cos squared x equals to 1. So 1 over cos squared x, and therefore 1 over cos squared is actually sec squared x. So therefore, you have this formula derived. Okay. So for sine inverse x and also cos inverse x and tan inverse x, all this will follow using the similar approach just now, right? So now I can continue by letting y equals to cos inverse first or sine inverse first. Sine inverse. So you let y be sine inverse of x. Then you change it x in terms of y. So you have x equals to sine y. So in this case, what do you get here is dx dy is equal to cos y. Now I want dy dx, so you flip. So dy dx is equal to 1 over cos y. So using the hyperbolic identity, 1 over cos y basically means 1 over. Now by right, you should have, okay, be careful. Now you are using the identity again. So you have cos squared y equals to 1 minus, sorry, 1 plus, right? Should be 1 plus. 1 plus sine squared y. Now you see, by right, you should have plus minus, Cos y should be plus minus square root of this answer, right? But we cannot take the negative value. Can anyone recall what is the reason? What is the reason we do not take the negative value?
The range of cos y is more than 1, more equal to 1.
Yes. Yes. Cos y always has a value which is greater than or equals to 1. Okay. So since cos y always greater than or equals to 1 for all y, therefore you reject negative. Therefore, reject negative expression. Okay. Expression. Therefore, you know that I am going to use the positive only. Yeah. So therefore, I have dy dx is equal to 1 over square root of 1 plus x squared, right? Because your sine squared y is actually x squared. Sine squared y is actually x squared. So it's actually x squared. Okay? So that's how you prove this one, right? So move on. Next one, we look at cos inverse. So let y equals to cos inverse of x. So you know that x is equal to cos y. So x equals to cos y means dx dy equals to sine y. Okay, so dx dy equals to sine y would mean that dy dx is 1 over sine y. So using the identity again, using hyperbolic identity again. So you should be able to get sine squared. So we have cos squared y minus sine squared y equals to 1. Okay. So using the identity, I want sine y. So I want sine y means sine y, sine squared y is equal to cos squared y minus 1. Right. So cos squared y is actually x lah. From here, you know that this is x. So you can put in, right? So this is actually equals to x squared minus 1. Now by right, I should have plus minus square root of x squared minus 1. Okay, by right, I should have this one. Now the question is, which one should I choose? Which one should I choose? Sine y is equal to plus minus square root of x squared minus 1. Which one should I choose in this case? So you will have to go back to the graph again, shine y. Sorry, cos inverse, cos inverse. So I give you the graph earlier, cos inverse. You look at the cos inverse graph. So the cos inverse graph, you look at this part here, is always, dy dx is always positive, right, for this region. I need to scribble. For cos inverse, because we are considering this part, so you can see that the dy dx is always more than 0, isn't it? Therefore, we are using this, and hence I can only accept the positive value. So therefore, what is my dy dx? So my dy dx is equal to 1 over square root of x squared minus 1, considering the graph.